You might remember the images last month of a Chinese spacecraft blasting off for the moon. Well, it's due to return to Earth in the coming hours, carrying fresh samples of moon rocks and debris. Chinese ground crews are awaiting the landing of the unmanned mission, and with it, the first lunar samples in more than 45 years.
For centuries, the moon has captivated and stirred our imagination, serving as a realm of mystery, wonder, and perpetual speculation. However, what if we were to inform you that the conventional teachings regarding the moon's origins, composition, and true purpose might be entirely misconstrued? In a groundbreaking and recent study, the esteemed physicist and futurist Dr. Michio Kaku has unearthed an extraordinary revelation about our celestial neighbor that stands poised to challenge the very bedrock of our comprehension. What unexpected insights has Michio Kaku brought to light on this occasion, and how do they disrupt our conventional beliefs and understanding of the moon? This is Reveal the Mystery. If you are curious to learn mysteries of the world, space, and beyond. Michio Kaku asserts that dinosaurs confronted a critical obstacle, a lack of a space program, ultimately leading to their extinction. Despite the playful manner in which the esteemed physicist introduces this example, the underlying message carries profound urgency. To avert a fate akin to the dinosaurs and stave off extinction, Kaku underscores the imperative for a Plan B, or more aptly, a Planet B. Ensuring humanity's survival in the long term necessitates evolving into a spacefaring civilization that establishes colonies on other celestial bodies. This perspective is not confined to Kaku alone. Even Stephen Hawking contended that the key to our sustained existence lies dormant within the expanses of space. What better way to initiate this endeavor than by leveraging the galactic springboard readily available to us? Despite the last manned moon landing occurring over 50 years ago, Kaku expresses optimism about the resumption of human visits to the moon on a grand scale. Envisaging a future where our grandchildren might honeymoon on the moon, given its proximity of only 3 days away, Kaku's prediction may be perceived as bold in light of current circumstances. While international space agencies plan moon missions, NASA's Artemis program faces temporary suspension due to financial, legal, and technical reasons. Originally slated for next year, the revised plan now targets a launch period between 2026 and 2028. Contrary to initial impressions, Kaku suggests that the situation is not as pessimistic as it may appear. The Chinese, breaking a 4-decade hiatus, accomplished an unprecedented feat, successfully bringing fresh moon rocks back to Earth. Launched on November 23, 2020, the Chinese space probe Chang'e 5 touched down on the moon's surface, collecting samples. This extraordinary achievement challenges prior assumptions, revealing that the moon is not as arid as once believed. The samples, particularly from Chang'e 5, indicate the presence of water across the entire lunar surface, offering promise for potential human utilization in the future. Scientists estimate the lunar water reserves at a staggering 270 billion tons, signaling the commencement of more ambitious goals beyond the recent Chang'e 5 and Artemis missions. The international space agencies are nurturing dreams of establishing permanent lunar bases in the foreseeable future, and water is a linchpin in these plans. Its significance goes beyond providing drinking water for lunar settlers. It holds the potential for oxygen and hydrogen production, 5 times more water than the volume of Lake Constance. Despite the immense implications of this discovery, the actual finds are minuscule, with glass beads measuring less than a millimeter in size. These beads likely formed when meteorites impacted the moon's surface. The prevailing theory suggests that molten material rising from these impacts is bombarded by high-energy solar particles, leading hydrogen nuclei in the molten material to combine with oxygen, forming water or hydroxide ions. These negatively charged ions result from the reaction of bases with water. This process could mean the Moon has stored up to 270 billion tons of water in this manner. To put this in perspective, the volume of Lake Constance is just under 50 billion cubic meters, where 1 cubic meter of water roughly equals 1 ton. The glass beads aren't the sole water reservoir on the Moon. According to existing knowledge, frozen water is also present in significant quantities in the polar regions. In these areas, water lies dormant at the bottom of craters, with the lunar South Pole alone purportedly holding an amount equivalent to Lake Constance. Unlike the crater reservoirs, water can be more easily extracted from the glass beads, requiring heating to over 100 degrees Celsius, according to researchers. The Chang'e 5 discovery holds additional excitement. If water globules exist on the Moon, they could potentially exist on other celestial bodies lacking an atmosphere. Another lunar treasure unearthed by the Chinese probe is a previously unknown mineral named Chang'e, containing helium-3. This mineral holds promise as a future energy source. However, the plans to return to the Moon and establish permanent stations extend beyond scientific exploration. The Moon is perceived as an untouched treasure trove of raw materials beneficial to Earth. Despite the potential wealth of resources such as helium-3, iron, titanium, and gold, the current economic viability of moon mining is questionable. The exorbitant transportation costs between Earth and the Moon, estimated at $80,000 per kilogram over the nearly 400,000 kilometers distance, coupled with the expenses of exploring rich sources and building mining infrastructure, pose significant challenges. The feasibility of tapping into lunar resources to fuel Earth's engines remains uncertain, with the timeline for such endeavors still written in the stars. Moreover, we face a significant challenge in the current infeasibility of commercially harnessing helium-3. Simply put, this scarce isotope, touted for facilitating nuclear fusion without producing harmful waste, necessitates merging with hydrogen in reactors to generate helium-4 for energy production. However, nuclear fusion technology remains in its early developmental stages, with experts predicting it will be at least 50 years before the requisite facilities are accessible. The impediment is vast, and although financial considerations currently complicate lunar exploration, Michio Kaku foresees this obstacle soon crumbling. He envisions a growing interest in lunar exploration in the coming years, attributing it to forward-thinking individuals such as Elon Musk and Jeff Bezos. Kaku points out that these once-children dreamers of space travel now wield the financial means to construct moon rockets at their discretion. Elon Musk, in particular, not only envisions lunar exploration, but also aspires to propel humanity to Mars. Is this Mars initiative the previously mentioned Plan B for humanity's survival? Kaku acknowledges the substantial cost factor, but anticipates a shift in the near future. Currently, the cost of transporting goods to Mars hovers around $2 million per kilogram, but decreasing prices, especially with the advent of reusable rockets, play a crucial role. Kaku stresses the significance of reusable space travel, drawing parallels with the automotive industry. He underscores that the transition to reusable rockets will unlock new opportunities, rendering space travel more economically viable. Kaku argues that leaving the confines of Earth is imperative for humanity's survival. He dispels the idealized image of Earth as a nurturing mother, emphasizing nature's ruthless tendency to eliminate inefficient life forms. To thrive on Mars, Kaku suggests terraforming, an undertaking to create a habitable environment on the red planet. By deploying solar satellites to Mars that beam sunlight onto the polar ice caps, a warming process is initiated. A temperature rise of 6 degrees on Mars triggers a self-sustaining greenhouse effect, effectively terraforming the planet. However, Kaku clarifies that the objective is not complete abandonment of Earth for Mars. Instead, it involves establishing a self-sustaining settlement on Mars, serving as insurance, a Plan B, while preserving Earth's resources. Kaku concludes by encouraging viewers to subscribe for more insights into the latest and most thrilling space discoveries on the horizon.